The Shopfloor connected accelerator is located in between the data sources. This is the Shopfloor sensors or the PLCs, basically in the edge, and acts as an intermediate element between those and the KYKLOS backend. As you can see there, the main infrastructure is deployed on a PCB that is already manufactured and fully working. We are applying a proprietary license to this, so we won't be releasing any open source data regarding the board itself. The Shopfloor Connected Accelerator provides several benefits to circular manufacturing. In principle, we are assisting in the development and deployment of tools, applications, and services enabling circular economy strategies. And more specifically, what we are doing is providing a common infrastructure to deploy reusable and resource-efficient solutions for edge computing, which in turn aim at reducing the edge-to-cloud latency and increase energy efficiency. In addition, we are also providing seamless sensor integration, as for instance, in the integration of the camera in the standard pilots, and all wrapped around the IoT paradigm. The main capabilities of these and functionalities of these technical components is the capability of offloading certain tasks that are usually or traditionally performed in the cloud, and we deploy them on the edge to improve security and privacy, so that data can be processed on premises and they don't need to actually leave the facilities. With this, we also reduce latency in the processing, and in turn, we reduce the network overhead. In parallel, we are also achieving edge level or providing edge level acceleration, in which we have a hardware-software hybrid system, and we work with hardware processors to deploy, for instance, machine learning applications or machine learning algorithms for predictive maintenance. And in order to provide flexibility, we're relying on FPGA dynamic reconfiguration. What we're going to be showing in this demo is, as you can see here in the camera, I'm showing the accelerator. So we have the Shopfloor Cognitive Accelerator board here. We have inside the chip, we have it's a dual system in which we have two ARM processors, and then we have the FPGA matrix. So today we'll be only using the software processor, so no hardware acceleration for this demo. And on the other hand, I have this little Raspberry Pi 4 here, which is going to be, which is the device that we've been using for prototyping the camera acquisition. So if you can see, this is one of the cameras that we have. This is one of the cameras that we want to deploy onto the standard pilot. And the idea would be to have a similar node to this Raspberry Pi attached to the camera, and then send data through Wi-Fi to the accelerator, in which we will be doing the processing. So as I was saying, I'm going to be showing two things today. The first one is going to be the Modbus communication. So if you allow me a second, I can switch to this, and I can show you this demo. So what you can see here at the top, you can see the this little part here is going to be showing the server. So I have a Modbus server running on my PC, on my computer. Then you have here at the bottom left the actual shell coming from the accelerator, and then I have some packet monitor here, so that I can keep trace of the packets being sent through the Ethernet network. So if you allow me for a second, I will start the server. Then I will also start the packet capture, and now I will run the client. So in this basic example, what I'm doing is taking as an let's say example mapping the one provided by Pindos. I'm performing some dummy read request to all the different let's say registers that we have in the PLC. So for instance, regarding the drilling number one, we have the currents and so on and so forth. And as you can see, I have here all the traces coming from the communication. So you can see in here, for instance, well, since this is a dummy example, I'm performing some writing operations, but I'm also performing some read operations that you can see here.
So for instance, I'm reading some registers starting from this address, and then I'm retrieving the data from those registers. So that would be the first part of the demo. And now I will switch to the other one, which is the one regarding the camera acquisition. So this would be in the standard pilot. And basically the idea here is that we have been working with two modes for the time being. One is, let's say, streaming-based acquisition. So what you can see now is the camera acquiring images in real time in the Raspberry Pi. There's a bit of lag because I'm sending back the images through Ethernet connection. So we have a bit of lag in there, but you can see there the live feed. And apart from that, we've been also working with the possibility of acquiring static images and saving them into the file system. So I'm taking a couple of images right now. I can move this around and stop this. And what you can see is, I think you're not seeing anything right now, but you would be able to see all the different images that we have captured there. So that would be pretty much everything.